Okay, so hi, my name is Jillian. I'm going to do another practice kinematic one-dimensional word problem. This is part 2. Yeah. Okay. So the next problem that I would like to do for you guys is, I'll read it to you. A car increases its velocity from 15 meters per second to 25 meters per second in the distance of 20 meters. And the first question we're doing is find the magnitude of this acceleration. So, as before, I have these 3 key equations. You can watch part 1 if you want to know the definitions of each variable. Yeah. Okay. So, moving on, we're just going to make a table because tables make everything simpler. And this has all the variables from these 3 key equations. So, here's what we have. We know that the car's initial velocity is 15 meters per second, and its final velocity is 25 meters per second. And the distance is 20 meters. So I see that it's a distance of 20 meters. That's like the displacement, but I'm just going to say that the initial position is 0 and this final position is 20. It doesn't really matter because I could have chosen 10 and 30 or whatever. It doesn't matter. Okay. Or maybe it might. I don't know. Don't take my word for it. Okay. So, okay. Looks like we're filming again. Okay, so, sorry. But the first question is to find the magnitude of this acceleration. When it says that, it's just asking for the value of acceleration. So we're going to be solving for A. Okay, so the equation that I'm going to be using for this problem is this one right here. Because we know VF, we know VI, we know A, we know D, but we don't know A. And the other ones use stuff that we don't, well, I mean, this one is the simplest. And the other ones would have multiple variables, which we don't want. Okay, so I'm just going to start plugging in the numbers for this equation right here. So you'll get 25 squared minus 15 squared equals 2a, and then we found out that the displacement is 20, because remember that was in the problem and I talked about that over here. Okay, so I'm just going to leave those and do them on my calculator, but this is equal to 40a, and after solving, you will see that it is equal to 10. A is equal to 10. Cool. So, the acceleration of this car is 10 meters per second. Okay. Yay. So let's do part B of this problem. It asks us to find the time it takes for the car to travel the distance. Okay. So, I'm just going to erase this. We already know that A is 10 because I put it in the table. So, to find time, I can choose this first key equation, or I could do this one, but this one is simple. So it would be 25 equals 15 plus 10t. Now I'm just going to solve. Okay, so this is 10 equals 10t. Wow, this is really simple. T equals 1 second. Wow, it looks like 15. Cool. So that's all of part 2. I guess I could do one more. Okay, so, alright, the next problem is, a bike accelerates uniformly from rest to a speed of 7.1 meters per second over a distance of 35.4 meters. Determine the acceleration of the bike. Okay, so let's start plugging in our variables in the table. Okay, so we don't know acceleration, we don't know time, but we do know that, that the distance is 35.4. So I'm just going to say that the initial position is 0, and that this is 35.4. Again, like we could probably start anywhere, but this is easiest. Okay, sorry. Okay, and then we also know that if the bike comes or accelerates uniformly from rest to a speed of 7.1, then we know that. Okay, yeah, that's the velocity. We can tell by the units because it's meters per second. Okay, so sorry. It comes to rest, which means its initial velocity is 0, but final velocity is 0, but its initial velocity is 7.1. Okay, so now we have a bunch of, well, just like 2 variables that we're going to be solving for. But mostly we're just solving for A, because that's what the problem asks for. So I'm going to be using, actually this third key equation again. So I'm just going to start plugging in values. 2 times question mark. We'll just put that as A, times 35.4. Okay, I'm just going to, okay, this is negative 50.41. I just did it on my calculator. Yeah, equals 2 times 35.4, 70.8A. I'm just going to divide, so it's 50.41 divided by 70.8, and that will give me that A equals negative 712. The IB program calls for 3 significant figures, so that's what I did. And you'll notice that it's a negative amount for acceleration. And if you think about the problem, it makes sense because it's coming, or it's going, and then it's coming to rest. And so it would be a negative acceleration because it's decelerating. Okay, so that's it. Yep, okay. So negative 0.712. And then if you wanted to, you could solve time by using another one of these, but problem doesn't ask me to do that. I'm not going to. Thank you.